When we study motion in a circle, it is considered one type of motion. So we will use the same quantities to describe the motion, quantities that we have used in kinematics in AS, such as displacement, distance, velocity, speed, and acceleration. So the only difference is when you move in a circle, we can describe the displacement in terms of angle, the velocity in terms of angle, as well as the acceleration. We call it a special name called centripetal acceleration. So let's first start off with your displacement. If you were to consider an object, let's say moving from one point here to this point here, you can describe the motion by the distance that the object travels, which is this s. So this is called the distance traveled, which is not looking at the direction, because we are moving in a curve. So we just say the total distance traveled is s. However, we can also describe the motion in terms of the angle that is being covered, which is this, which is called theta. So we can call this angular displacement. But when we measure this angle, we can use the SI units called radians. So how do we get 1 radian? Remember, this is what you learn in your additional maths. That the angle radians theta is defined as the ratio of the length of the arc to the radius, right, which is this. So therefore, if you want to get 1 radian, definition of 1 radian, which is required in your syllabus, you can get one radian here if the value of s and r are equal. So you can call it the angle subtended at the center of the circle when the length of the arc is equal to the radius of the circle. So if we are talking about one complete revolution, let's say the object starts from here and travels 1 round and comes back to here, then the distance that is traveled is actually 2 pi r. So if we take this formula, theta equals s over r, so the s we substitute as 2 pi r, and then you divide by the r, you get 2 pi radians, which is why for one complete revolution, the angle is 2 pi radians. So this derivation is also required in your syllabus. Now, if the question requires you to convert from degrees to radians, we multiply pi over 180. And if you want to convert radians to degree, we multiply by 180 over pi. Therefore, there's a definition of angular displacement that you need to memorize. This is the definition. Angular displacement is defined as the angle turned through from a reference point in a specific direction, and the SI unit is radians. Now we can also talk about angular velocity. So what is angular velocity? So remember, we were saying that if, let's say, an object starts moving from, let's say, here, all right, use a different color. Let's say it moves from here to here. So we can talk about the speed, how fast the object travels, by using the distance traveled divided by time. But that would be linear speed. So that would be like v equals to s divided by t. We can also describe the speed at which the object is traveling by the angle that is covered, or the angle that is turned through per unit time. So if we call it angular velocity omega, you can call it angle turned through per unit time. So we take the angle that is covered divided by time. Okay, so that is angular velocity. So remember, angular displacement is measured in radians. So therefore, if you take theta divided by t, so you will get the unit as radian per second. So that's called angular velocity, and the symbol is omega, not w. So this is omega. So there is a relationship between linear speed and angular velocity, because the faster you move, right, the distance that you cover in 1 second, obviously the angle that you cover per second also faster, right? So what is the relationship? Now remember, we said so the v is equals to s divided by t, right? So therefore your s equals to vt s equals to vt. So the first equation. Now remember also from the previous slide, remember your s equals to r theta? It comes from the equation what? Theta equals to s over r, right? So you get s equals to r theta. So you have this second equation here. So if we equate these two, because s equals to vt and s equals to r theta, then you get vt equals to r theta, correct? Then you bring the t over, then you get v equals to r theta over t, and theta over t is omega. So this is the formula V equals to R omega, you must know, must memorize. You know why? It enables you to switch from linear speed V to angular velocity omega, or angular velocity to linear speed. So there's a formula to convert. Now, there's also another two useful formulas. From this formula of omega equals to theta over t, if we consider one complete revolution, that means one complete circle, what is the angle that you cover? How many radians? Because the unit is radians. So you take 2 pi, and the time taken is period, so you get 2 pi over t. Since your 1 over t is f, so you get omega as 2 pi f. So these two formulas you can use for all circular motion. Okay, now this is more useful than just theta over t, because theta over t can be any time, can be any angle. But for every circular motion, if the period of the circular motion or frequency is specified, then you can find the angular velocity. Similarly, from this formula V equals S over t, for one complete revolution, what is the distance covered? Which is circumference, right? Alright, so it's 2 pi r divided by the period. So this formula also can use for all circular motion. So these three formulas, which I boxed up, are the most important formulas for speed. So for this part, we have covered the speed, linear speed and angular velocity. Alright, so after we have learned about distance, displacement, velocity and speed, let's talk about acceleration. Now, if an object moves from one point here to another point here at constant linear speed, let's say 5 meter per second here, v, and also 5 meter per second here, and let's say the omega is also constant, let's say 0.5 radian per second, here also 0.5 radian per second. Now, is the object considered to be accelerating? Now, because we understand that acceleration is defined as rate of change of velocity, so therefore if there's a change of velocity, there must be acceleration. So the velocity at this point may have the same magnitude 5 meter per second as this point, which is also 5 meter per second. But the direction of the velocity is always given by the tangent to the curve at that point. So meaning to say the direction of the velocity is here. Similarly, direction of velocity at this point is also tangent to the circle. So because the direction changes from here to here, velocity is considered to have changed, and therefore there is acceleration. But the question is, what direction is this acceleration, such that it only causes a change in direction and not a change in magnitude? So we have actually covered a little bit of this in AS, but I will revise again. So we say that if the velocity is, let's say, to the right, and your acceleration is also to the right, it will result in the speed increasing. But if the object is moving to the right and the acceleration is moving to the left, and acceleration is to the left, then you will result in your speed decreasing. So logically, if the object is moving to the right, but the acceleration is 90 degrees, which is vertically upwards, then therefore the magnitude of the velocity will remain the same. So what will only change is the direction, because two vectors which are perpendicular to each other, which is these two, cannot affect each other's magnitude. So therefore it will only result in a change in direction. So the conclusion is that whatever acceleration acts on this object at this point has to be perpendicular to the velocity in order to only change the direction and not the magnitude. So therefore the acceleration has to be 90 degrees to the velocity. So we have also learned in mathematics that if you draw a tangent to the circle and then you proceed to draw a line 90 degrees to the tangent, which is called your normal line, this normal line will always point back to the center of the circle. So which means to say the direction of the acceleration at this point is towards the center of the circle. Similarly, when you come to this point, the direction of the velocity is tangent, and direction of the acceleration has to be 90 degrees to it, so it will then lead back to the center of the circle. So therefore, this acceleration in circular motion will always be pointing towards the center of the circle, which is why we will call this type of acceleration centripetal acceleration. So centripetal acceleration is the acceleration towards the center of the circle. The opposite to centripetal is actually centrifugal, which is opposite to the center of the circle. That means away from the center of the circle. Now, this centrifugal acceleration or centrifugal force does not really exist, but we tend to feel it, but it doesn't really exist. For example, if let's say you were in a car traveling in a circle, and as the car is making a very fast circular motion, and if the door opens, we feel that we will be flying outwards, right? We will feel ourselves being thrown outwards. However, you will not actually fall outwards, but what will happen is you will move tangent to the circle because of your direction of your velocity, and that's your inertia, so you move tangent to the circle. But how come we feel that ourselves being thrown outwards? It's because we are always trying to move tangent to the circle because of our direction of our velocity. However, the car door keeps pushing you inwards to move in a circle. So we're actually moving forward, but if the door keeps on pushing us inwards, which is why we feel ourselves being thrown outwards. But it does not exist, right? We will move tangent to the circle. So this formula for centripetal acceleration, the good news is you do not need to derive it, so you can straight away memorize this, which is A equals to V squared over R, because the derivation is actually too tedious. So we say that acceleration, centripetal acceleration is V squared over R, or R omega squared. Either one is okay. If the question wants in terms of V, we use this. If the question wants in terms of omega, we will use this. But if you remember any one of these formula, we can derive the other one by using the conversion V equals to R omega. For example, if I want to convert this to omega, I just substitute V here as R omega, and then I will get A equals to R omega squared. So when you have a centripetal acceleration, logically we should also have centripetal force, because Newton's second law says that when you have net force, you should have acceleration. So what will happen is, since your acceleration here is centripetal acceleration, when you multiply by the mass, you get centripetal force. So centripetal force is either mv squared over r or mr omega squared, depending on whether the question wants you to write in terms of v or omega. And then some students then get confused and they ask me, so when do I use F equals to MA, and when do I use F equals to MV squared over R or MR omega squared? So the answer is actually quite straightforward. Whenever you see a net force acting on the body and it causes a linear motion, that means moving in a straight line, then we can just use back our AS formula, F equals to MA. However, if we are talking about circular motion, which means to say the resultant force or the net force doesn't cause a linear motion but causes a circular motion, then that net force is a special type of net force called centripetal force. Then we can use the formula mv squared over r or mr omega squared. Now also remember that centripetal force is a net force, which means to say it cannot exist on its own. Now what I mean is, for example, if you had a block resting on the floor and you apply a force of, let's say, 10 newtons, and there's the frictional force of 3 newtons, then that would give you a net force of 7 newtons. However, if this exerted force of 10 newtons and this frictional force of 3 newtons does not exist, then this will also cease to exist. So meaning to say, centripetal force is like this net force. There needs to be other forces acting on the object, such as weight, normal reaction, tension of a string. All these will add up together, for example, like these two, and give you a resultant force. So that resultant force would then become your centripetal force. So always remember, centripetal force cannot exist on its own. It needs to be provided by some other forces.